So we're here at the Open Fabric Alliance workshop with Doug Ledford. Doug is a principal engineer for the InfiniBand division at Red Hat.
Not really a division, but for the InfiniBand products. So I handle all of the engineering for that inside Red Hat.
Very nice. What were your goals coming in, Doug, as far as the workshop goes, and how is it going so far?
Okay, so I had a number of goals. Well, one of them, we were doing a small talk about the recent changes that OFID made in how they're going to work with the upstream community and how they're going to work with us distributions. And those changes are fantastic. They've been what we've been asking for years. The last workshop I was at was in 2007, and I was saying back then that they needed to make these changes. And so it's actually been a little bit of a battle to convince everybody that the changes needed to be made. But eventually, the battle and the war is now over, I guess. So I was here to talk about that, and then here to see some people just kind of networking, because I think to a certain extent the InfiniBand space has, I don't want to say stagnated, but we haven't seen as many new installations and everything as we used to. And so I think there's a lot of room for the InfiniBand market to grow, and especially with the advent of Rocky or IBOE, whichever one you prefer to call it. There's a lot of room for verbs use to grow and RDMA programming to grow. And so one of my goals coming here was to talk with some other people about ways to make that happen. And so I've been kind of quietly going around and talking to various people about exactly that. So.
Well, what is the history between Red Hat and OFAD being, of course, Open Fabric Enterprise Distribution? What's the history there?
That's a long, long history.
We don't have to
so this started back in about 2003. When primarily Mellanox at the time and also Silverstorm, and they wanted to get their drivers into our product. And in addition to that, their own products had interoperability issues, which hadn't been a real big problem for them, but as some customers wanted to grow their cluster, they didn't necessarily want to be locked into the same vendor. And that's when the interoperability became a problem. So the customers were complaining about interoperability. They were complaining about the fact that they had this software that they had to download and install that wasn't part of the OS, that was tricky to get installed, was tricky to get right. And so out of that was born the Open Fabrics Alliance. And they started putting together a software stack that worked across all the hardware instead of being vendor specific. They then came to the distributions and they said, listen, we'd really like you to put this in because our customers really want it and we think it's the best thing to do and we'd like you guys to support our stuff. And we're like, hey, it's a new toy, so sure, we're going to play with it. And so we started putting this stuff in. And pretty quickly there became evident there were some compatibility issues. And so one of the things that OFID was originally created to get around was the fact that from one version of a package to the next, it may not work with a different version. Again, if you had libibverbs 1.0.5, and then you upgrade to libibverbs 1.0.6, and you also had librdmacm 1.1.12, the 1.0.6 libibverbs may no longer work with that librdmacm, and if they don't work with each other, your application breaks because it needs both. And because of this, you had to upgrade both of them at the same time. And so this is what OFID was created to get around. It was to create an entire group of software that worked together with no guarantee that the version of software, of any of the software in it, would work with other versions of software. It was just this one set of packages would work. So that's where OFID started. And it was something we needed as a crutch, a stopgap measure. We wanted to get people's systems up and running reliably. But we didn't, I knew at that time anyway, that we did not want this to go on long term. This was a crutch. And as crutches often are, when they're used long term, they get really hard to throw away. And so that was the problem, and that's what took some time to get around it. And so people had to wrap their heads around the idea of making one piece of the software work with multiple versions of other pieces of software using API compatibility methods and standard practices that are around in the software industry, but they're time consuming and they're a little bit onerous to implement. And so once we got that into their minds and got them on board with that, that's when it became possible to go ahead and get rid of OFID and put the crutch away and go ahead and make the entire software stack compatible between the different versions of software packages.
Very nice. So talk a little bit, if you will, about Red Hat's approach to RDMA and other kernel bypass applications.
Well, there's not very many kernel bypass applications, really, to be honest. RDMA is the number one, and our approach to it is pretty simple. We think it is a very valuable technology. We think it's an important technology. We think it's going to be a big part of systems moving forward. So we support the InfiniBand, we support iWork, we support the newer Rocky and IBOE, and we're going to support all of those going forward. And we support them with MPI applications, we support them with other applications such as DAPL, we support the direct IB verbs interface, and actually we'd like to see the support grow, and we'd like to see some more simplistic interfaces that can utilize RDMA come about. And we support them with the in-kernel methods as well, like ISER and SRP and IPO-IB. We support all of that stuff. So we support it across the board, and we're going to be supporting it long term. So it's a very important space as far as we're concerned.
Generally, how does that relate to high-performance computing and specifically via Red Hat or through Red Hat?
So we have SKUs inside Red Hat that are specifically designated for high-performance computing. And those SKUs are intended to be something that's suitable for a compute node. And with a compute node, you don't need a lot of the things you need on a general purpose server, that kind of stuff. And so we maintain SKUs for that, and we're going to. We maintain similar support on the server. So if you want to use it outside of an HPC node, but let's say you want to do a small web farm with a high-end interconnect, we support that. And so really we support it across the board on all of our products. And we have specific products for the HPC, for the server farms, and for others. I think that covers it.
Sure. Well, where do you see all of this headed? I mean, let's look down the road 3, 4, 5 years. How does all this come together and represent something that is foreseeable?
All right, so my crystal ball. So my crystal ball take on where things are going to go. I'm actually very excited about the talk that Jim Pinkerton from Microsoft gave. And the reason I am is because they took RDMA and put it into SMB 2.2. And so they put SMB into a place where it's positioned to be used, or they put RDMA into a place where it's positioned to be used in the data center, not just in HPC. And the reason that excites me is because I think that this is going to help add to the momentum of RDMA technology. And that's one of the things I was talking about. I think the RDMA technology has needed a little bit of a push for a while. And this is primarily because of how difficult it can be to program to the verbs interface. Well, for the advantage of RDMA on that product that he announced or was talking about, you don't have to know how to program verbs. And so this is going to help push the RDMA stuff into the data center and not just the HPC space. That's going to help give more volume. With the volume comes the economies of scale. It's going to drive prices down. That's even going to help things even more. All of these things are going to be to the advantage of RDMA technology. And then once you get more ubiquitous, then the RDMA technology is going to be programmed for more in addition. And I see that as a big win for the RDMA space. And then you add that to OFID's recent decision to get the drivers into the distributions and in box. This again, and Ira Winey had mentioned this in his talk, that in order to be ubiquitous, the University of New Hampshire testing lab can't be testing OFID to see how RDMA works on these platforms. They need to test out of the box SUSE, RHEL, Windows. When they test these things out of the box, that means it is everywhere, and that's exactly what we need it to be. That's what's going to make everything ubiquitous, and once it's ubiquitous, this technology is going to have the ability to take off far greater than it has. Instead of having a few applications written to RDMA, you're going to have hundreds. And when that happens, then you'll be able to fully utilize the fabrics, fully see the benefits of the improved methods and models of communication. And that's going to help everything. So.
Well, can you give me a concrete example of that? I mean, maybe something in the big data realm?
So they're working on stuff with well, we've been watching talks with the Hadoop and everything else. From my standpoint, what I'm working on is an API to help a regular sockets programmer take advantage of RDMA. And so we haven't reached version 1.0 release yet for this. I was hoping to get it ready to go by June of this year, or when we run our Red Hat Summit. But right now you have MPI applications. You have most MPI applications, written to use verbs. Then you have the financial sector, which are, again, a limited number of applications, very tightly controlled, related to the Wall Street firms and whatnot. You don't have a whole lot more in terms of RDMA applications, and what we want to see is that to change. Getting RDMA into the data center provides incentive to use RDMA in applications that don't reside in the HPC space. So can I give any examples? Well, pretty much anything. That's kind of the point.
Yeah.
It's wide open.
Right.
It's the matter of fact, it's the lack of examples that make me think there's a lot of room for improvement here.